Welcome guys to MathTech once again, and I'm glad to have you guys here today. And today we are back on another episode of the Maths series. But before I kickstart, I just want to remind you that our private classes are still ongoing. Don't fail to enroll for our private classes. The numbers are on the screen. You can send a message to the WhatsApp contact, or you send a call across to us, and we'll respond immediately. And one thing, before we go to the class, we start the class. Please don't fail to like this video, don't fail to share to others, and most importantly, don't fail to hit the subscribe button and subscribe to MathTech channel. Thank you so much. So in today's episode of the Math series, we'll be talking about decimals, approximation, fractions, and percentage. But this is how it will go. We might not touch everything in just this video. We might split it having part 1, part 2, part 3, possibly part 4. But let's hit the nail on the head immediately. So now today we're talking about decimals, approximation, fractions, and percentage. Now start with approximations. Approximations are rough estimates of calculations. Approximations are rough estimates of calculations. To approximate a given number is simply obtaining the estimate of a given number of significant figures, decimal places, or to the nearest whole number. Please take note of what is written here. To approximate a given number is simply obtaining the estimate to a given number of significant figures, decimal places, or to the nearest whole number. And now, let's go to decimal. Talking about decimals, I'll be more practical, and at some point I'll also give some theories. So talking about decimal, an example of a decimal number: 1.65, 0.0264, 39.7. Now these are examples of decimal numbers. Now, talking about decimal numbers, just a system of having a decimal, having a whole number, then having a decimal, then at the right hand side you are having values. Now it is wrong to pronounce this number as 1.65. It is right to pronounce this value as 1.65. It is wrong to pronounce this value as 1.65, but it is right to pronounce this value as 1.65. Now note that when approximating numbers, I gave you a definition of an approximation. I said approximation are rough estimates of calculations. To approximate a given number is simply obtaining the estimates to a given number of significant figures, one, decimal places. So when approximating a number to a given number of decimal places, let's say we are asked to approximate this to a 2 decimal place. You can see this mostly in exams, it is being written like 2 dp. So it means that rounding off the number to either the nearest 10, or you're rounding up the number to the nearest 100, or you're rounding up the number to the nearest 1000. That is just the concept of approximation. Now, approximations are rough estimates of calculation. They are rough estimates of what calculation? They are not really accurate. Now, let's say we are giving 0.0264. We are asked to approximate this number to the 2 decimal place. What are we going to be having here? We'll be having 0.03. Now, note, when approximating values to a given number of decimal places, now when you have values 0, 1, 2, 3, 4, at this point, let's say at this point, if the value we are having after 2 years was to fall in between 0 to 4, we would have rounded it down. That's leaving the result to be what? 2. But in a situation whereby the next number after the given number of decimal place is greater than or equal to 5, that's we see from 5, 6, 7, 8, 9, then we have to add 1 to the last value, which is the point of the decimal place. Now, I hit it again. Now let's say we are having here to be 0.0264, and we're also having 0.0235. Now, if we are asked to approximate this to two decimal places, which we have done here we will have 0.03. Now, why are we having 0.03? Don't forget the two decimal places. That's after the decimal point. The first two values, that's the two decimal places. That is 0 and 2. Now, the third value here now is now greater than 5. Now, when the third value is greater than 5, it is being rounded up. Now, rounding up means that you are adding an extra one to the given decimal place where you are asked to stop, which is 2. But now, when you are now adding up same number like this, we are asked to approximate this number to two decimal places. Now, don't forget, after the decimal, the second value here is what? 2. So it's supposed to be, this is where it's supposed to stop. But the next value here, which is the third value, is less than 5. So it means that it should be rounded down, so we still have it to be what? 2. So here will be giving us what? Here will be giving us 0.02. So that is just a simple concept about decimal places. That is just a simple concept. I will touch more examples on that. But let me still give you something using the concept of pi. So now, given the value of pi, which is 3.1415926, and there are still values that goes even down to infinity. Now, given these values, and we are asked to approximate this value to two decimal places, three decimal places, and four decimal places. Now, how do we get this done? Now, for the two decimal places, what will be having will be what? 3.14. Don't forget, since the third value here is less than 5, it means it will be rounded down. So what we'll be having here is what? 3.14. Now, for the three decimal places, we'll be having 3.14. Now 1, which is the third value, which we are supposed to stop. But the next value here is greater than or equal to 5. So the next value is 5. It means we need to round this up by adding 1 to this value, and this will be giving us what? 2. That is why most times when you're studying your mathematics using some textbooks, you will find that most textbooks might give you pi, or most exam questions might say use pi as 3.142. This is because it is being rounded up towards the 3 decimal place. Also for the 4 decimal place, we'll have it to be what? 3.141, and 5 is the next number. Look at the next number here. The next value here is greater than or equal to 5. So when you round up, add 1 to 5, you have what? 6. So that is just a pretty simple concept of decimal places. What you just have to do is practice this. Know that when you are given a number, to approximate a number to a given decimal place, 2 decimal places means after the decimal point, the second value there. Now, if the third value is less than 5, you round it down by leaving the value to be at that second value after the decimal point, not changing. But when the next number is greater than or equal to 5, you round it up by adding 1 to that second value, and that gives you the result. So you can explore with other examples. Don't forget we have, okay, let's see, 1.65 to 1 decimal place. What we'll be having here will be what? 1.7. So you can explore other examples. Check out for other examples. I just laid the foundation for you, and a pretty simple foundation. As we solve and go further in the math series, also in our problem solving video, you will definitely learn all of this one after the other. So now we'll be talking about significant figure. Similar process, knowing when to round up and round off. That's what we'll be doing here. Now we say numbers can be rounded off to a given number of significant figure. For any number, significant figure is counted from the left. The first significant figure, which is SF, I have to use the abbreviation SF, is the first non-zero digit. The first significant figure is the first non-zero digit, which we'll also treat that in the example now. But this is the whole concept of significant figure. Understanding place value. I think we've talked about that very deep basic arithmetics, and I explained all of that. So just go back, watch our video on understanding place value, and just the same experiment, understanding the units, tens, hundreds, thousands, 10,000, 100,000, millions, and as it counts further. So just that simple concept gives you an edge why learning significant figures. But note that for any number, significant figure is counted from what? The left. The first significant figure is the first non-zero digit. And now I'm giving us an example here that we can use to learn. Say, write off each of the following numbers to 1, 2, 3, and 4 significant figures. So let me do that immediately. Solution. So for I'll be rounding this 3, 4, 6, 5, 4. I'll start with the fourth significant figure first. Don't forget, the counting starts from what to the left. So I'll count 1, 2, 3, 4. So these are my first 4 significant figures. This is the fourth significant figure. Now look at the next number, which is the fifth value. Now this number is less than 5. Assuming this number was greater than 5, what we're supposed to do? We will round here up by adding 1 to this, and this will be what? 6. So fourth significant figure will give us a what? Here. 3, 4, 6, 5, and you can also put what? You can put 0. So this is the fourth significant figure for SF, and you can also do same value for the 3 significant figure. So 1, 2, 3, this is greater than 5. The first value here is greater than or equal to 5. So what we have here, we have 3, 4, 7, when it is rounded up, 0, 0, and we have here to be what? We have here to be what? 3 SF. Now, this is just a concept of place values. Now look at this. This is 34,654. Now if you are rounding this up, to the 4 significant figure, you are rounding this up to the nearest tens. Now, when you are rounding this up to the 3 significant figure, you are rounding this up to the nearest what? 100. Now, let's round it up to 2 significant figures, same value. So we are having just what will be 2 significant figures? That's 3 and 4. 3, but the next value here is greater than. You see, this next value here is greater than what? 4. It's greater than 5. Greater than or equal to 5. So we can pick this and round up. We have here to be what? 35,000. For these 2 significant figures. 1 significant figure, which is 1, 3. So we have here to be what? Since here is less than 5, you just have it to be what? 30,000. So now this concept of significant figure, just like when you are being asked a question, round a number like this to the nearest 100. If you are asked to round this value to the nearest 100, now look at this now. Look at this. The nearest 100, which is what? The 3 significant figure, which is the third value here, which signifies the 100, is greater than or equal to 5. But this one is greater than 5. So it will be rounded up to the what? 700, 654. Since it is greater than or equal to 50, so it means an extra one is going to be added to here, and the next value is here almost 0. So in the 3 significant figure, we are having here to what? 34,700. So let's also touch this example here for example 2. Say 126.735. So 4 significant figure, don't forget. Please always note this. The first significant figure is the first non-zero digit. but you can see that these are all non-zero digits. So we continue 1, 2, 3, 4. The next number is not up to 5. So we have 126.700. So we can leave it there and say 126.700, or we say 126.7. So this is one significant figure. You can see clean off the 0 and leave it to be 7. And this is our 4 significant figure. And 6 value here for 3 significant figure, we have it to be 1, 2, 3. The next value here is greater than 5. So we have it to be what? 1, 2, 7. And this is our 3 significant figure. The next value here for 2 significant figure, 1, 2, the third value here is greater than 5. So we have it to be what? 130, 130, and 2 significant figure. And for our 1 significant figure, the first value here, this is less than 5. So here will be what? 100. And this is our 1 significant figure. So now, you can try this third example by yourself. So I'll just give you a few seconds to do it by yourself. Try for the first significant figure, 3 significant figure, 2 significant figure, and 1 significant figure. Why I rush that way.
I need someone on this beat.
So now for the third example, this is what we'll be doing now, 0.046765. Now don't forget, we have cleaned that part. The first significant figure must be the first non-zero digit. The first non-zero digit. Now, first of all, start with our first significant figure will be what here? First significant figure should be the first non-zero digit. This is 0, this is 0. So the first non-zero digit here is what? 4. So this will be 1, 2, 3, and 4. So our first significant figure will be 0.04676, which is supposed to be the first value. But look at the fifth value. It is greater than or equal to 5. So we have to round this up by adding 1. We have here to be what? 7. And this will be our first significant figure. And also, for the 3 significant figure, 1, 2, 3. So we have 0.046. 7 is supposed to be the next value, but look at the fourth value, greater than 5. So we round it up and we have here 7 here will be what? 8. And this is our 3 significant figure. And for the 2 significant figure, we have 0.046. The next value here is 7. So round it up, add 1 here, we have what? 7. We have 2 significant figure. And for the 1 significant figure, we'll be having 0.04, which is the first significant figure. And that's the 1 significant figure. But looking at the second value here, it is greater than or equal to 5. So we round this up here. And here will be 0.05. And this is our 1 significant figure. So guys, I think we'll call it a wrap here, because we don't want the video to be too large, so that you can watch over and over and over and over to learn. And if at any point you are confused, you feel you have a question or a contribution, please drop it at the comment section. Don't fail to like the video, don't fail to subscribe and to share to others. Thank you so much guys for being part of this video, and this is just a part 1 of this topic: decimal, approximation, fractions, and percentage. So many things to learn under this topic. We have the simple and compound interest to learn. We have the percentage error to learn. We have fraction also to learn in this topic. So we still have a lot to deal with in this topic. So just stay tuned and follow our series time to time. We get you updated week by week. Please, for a while now, for like 10 days plus, we did not post a video. Yes, we had one or two issues, but that has been sorted out. And don't forget to be part of our private classes in the MathTech. Our private classes is ongoing. Parents, please make sure you enroll your children. Children, tell your parents to enroll you in our private classes. We can come to your house or we give you a venue where you can come and meet us. You get your class done in any niche which you desire. We have a tutor for you. Thank you so much and see you in our next video. Don't forget to hit the subscribe button. Thank you.